Welcome to this video based on the EEF guidance report to improving mathematics in key stages 2 and 3, this time looking at recommendation 3, teach pupils strategies for solving problems. What is problem solving? Well, problem solving generally refers to situations in which pupils do not have a readily available method that they can use. Instead, they have to approach the problem flexibly and work out a solution for themselves. To succeed in this, pupils need to draw on a variety of problem-solving strategies which enable them to make sense of unfamiliar situations and tackle them intelligently. The first guideline states that you should select genuine problem-solving tasks for which pupils do not have ready-made solutions. If pupils lack a well-rehearsed and readily available method to solve a problem, they need to draw on problem-solving strategies to make sense of the unfamiliar situation. Sometimes problem-solving is taken to mean routine questions set in context or word problems designed to illustrate the use of a specific method. But if students are only required to carry out a given procedure or algorithm to arrive at the solution, it's not really problem solving, rather it's just practicing the procedure. Let me show you an example. Routine problem solving involves practicing a procedure. For example, a sale in a shop advertises a jacket regularly priced at £125.98, but now selling for 20% off the regular price. You have £100 in your pocket. Do you have enough money to buy the jacket? This question is a framework or context within which learners practice applying percentages. These questions are themselves important to teach as they often place the four operations or fractions, decimals, percentages and so on in a practical context that the learner may encounter in their lives. This is an algorithm, which is a well-established sequence of predetermined steps that are executed in a particular order in order to carry out a commonly required procedure. But these are not the only types of problem we should teach. We need to teach problems that require the development of a strategy. These strategies enable pupils to make sense of unfamiliar situations and discuss and tackle them intelligently. Here's an example of using bar modeling to compare different strategies to solving an unfamiliar problem. Here's the problem. A sister is 4 years older than her brother. The total of their ages is 26. How old are they? One pupil used the bar model to solve the problem. Here it is. The brother's age and the sister's age plus 4 is 26. So b plus 4 equals 26. If you subtract the 4 from both sides, you get b plus b equals 22. If you then halve that, you get 11. Add the 4 years age difference to the sister, you get 15. So the brother is 11 years old, and the sister is 15 years old. Another pupil said, couldn't we just halve 26 and then add and take away 4? So their ages are 13 plus 4 and 13 subtract 4, which is 17 and 9. Another pupil said, no, you don't add and take away 4, you add and take away 2. And again, the teacher draws a bar model to show this. Here it is. So you've got your b plus your 4, and the bar model here shows that that 4 can't be subtracted and then added. It has to be 2 because that 4 is split equally between both b's. How does this help us to see whether it's 4 or 2 that you add and subtract? A pupil said, well, there are 2 lots of b in the 26. There is only one 4. So it was correct to add and subtract 2, not 4. Here are some more guidelines on effective teaching of problem-solving strategies. Consider organizing teaching so that problems with similar structures and different contexts are presented together, and likewise that problems with the same context but different structures are presented together. Pupils need to experience identifying similar mathematics that underlies different situations, and also to identify and interrogate multiple relationships between variables in one situation. This is essentially the importance of and difference between conceptual and procedural variation. Conceptual variation is the opportunity to work on different representations of the same idea. For example, you could represent the number 25, like I've done here, using deans, place value counters, and so on. In this context, the context of place value, that is, some of these representations reveal the value of the digits, others the importance of the position of the digits, others the order of the digits. Here's another example of conceptual variation. You can use various representations to show the multiplication problem 3 times 4. You can use the array you can see here with red dots. You can use a bar model. You can use a triangular arrangement or just the standard multiplication format. Keeping the question the same but representing it in different ways allows pupils to explore the underlying structure of the problem, helping them to make sense of it not just by getting to the answer, but understanding how that answer is reached. Procedural variation is the idea that you keep some things the same and only vary the key concepts you are teaching. Here is an example. In this set of problems, the numbers are varied, as is the unknown. This helps pupils to focus on the key concept by changing or varying the non-key concepts. As well as varying the unknown or number, you can also vary the method. We all do this quite a lot. For example, when adding two numbers, you can use a column method, various mental methods, partitioning, and so on. The final type of procedural variation I'd like to mention is applying the same method to a different but similar problem. This one really is a foundation of all our teaching, as when we teach a strategy, we often revisit it in future lessons. For example, if you are teaching pupils to estimate answers to addition calculations, you'll be asking them to apply their prior knowledge of rounding. Another guideline linked to what I've just discussed is that you should teach pupils to use and compare different approaches to problem solving. There are often multiple ways to approach a problem. Much can be learned by examining different solutions to the same problem and looking for similarities in solution approaches to different problems. Pupils will need to distinguish between superficial similarity, for example, two problems both about carrots, and deeper similarities relating to mathematical structure, which make similar strategies effective, such as two problems in different contexts that are both about enlargement. Teach pupils to interrogate and use their existing mathematical knowledge to solve problems. Pupils should be encouraged to search their knowledge of similar problems they have encountered for strategies that were successful and for facts and concepts that might be relevant. Encourage pupils to use visual representations. Help students to make use of appropriate diagrams and representations that provide insight into the structure of a problem and into its mathematical formulation. Use worked examples to enable pupils to analyze the use of different strategies. Worked examples or solved problems present the problem and a correct solution together. They remove the need to carry out the procedures required to reach the solution and enable pupils to focus on the reasoning and strategies involved. Worked examples may be complete, incomplete, or incorrect, deliberately containing common errors and misconceptions for learners to uncover. Analysing and discussing worked examples helps students develop a deeper understanding of the logical processes used to solve problems. Require pupils to monitor, reflect on, and communicate their reasoning and choice of strategy. While working on a problem, encourage pupils to ask questions like, what am I trying to work out? How am I going about it? Is the approach that I'm taking working? And what other approaches could I try? When the problem is completed, encourage pupils to ask questions like, what worked well when solving this problem? What didn't work well? What other problems could be solved by a similar approach? What similar problems to this one have I solved in the past? Pupils should communicate their thinking verbally and in writing using representations, expressions, and equations to both teachers and other pupils. That's all from me for now. Do join me for the next video on the fourth recommendation on enabling pupils to develop a rich network of mathematical knowledge. Thanks for watching.